Hello, Prosperivarians. The best school has come to stay in the city of Calabar. It is called Beryl International School. Take advantage of this opportunity now.
Tell me the best school, Beryl is the best. Tell me the best school.
Hello students, good morning to all of you. I hope you are all doing well and staying safe at home. And to officially welcome you to the second week of Beryl e-learning. It's time for mathematics class for ss1, and we look at the topic on the board: perimeters and areas of sectors of a circle. Perimeters and areas of sectors of a circle. Now, in our last class, we talked about measuration, where we said it's a process or method of measuring and calculating the lengths, areas, and volumes of plane shapes. And we also went further to apply the different formula in solving problems like that involves plane shapes, perimeters, and areas of different plane shapes. And we went further to look for the length of arcs of a circle. And we established the formula for finding the length of an arc of a circle. And we say it is denoted by theta all over 360 times 2 pi r. Length of an arc of a circle, we say theta over 360 times 2 pi r. The formula for the length of an arc of a circle. Today we're looking at perimeters and areas of sectors of a circle. But before we go into that, we first look at what a sector is. A sector is any fractional part of a circle that is bounded by an arc and two radii. The sector of a circle is any fractional part of a circle that is bounded by an arc and two radii. Now let's consider a circle with center O. Any straight line that moves from the center of the circle to any part of the circumference is a radius. We have a radius from the center to the circumference is radius. Here we have the radius. We start to level, we say A, B, C, D. Now, this part where we have A, O, B, this region is called the sector of a circle because it has an arc and two radii. An arc and two radii. An arc of the circle is any curved part of the circle. All these are arcs because they are curved parts of a circle. So we say a sector of a circle is bounded by an arc and two radii. So this is a sector. This is a sector because we have an arc and we have two radii. We have an arc and two radii. We have an arc and two radii. So we have sectors of circles. If you pick out the sector AOB, sector AOB, you have A. That's this region. Sector AOB. Now it has a two radii and an arc. We have already said that the length of an arc is given by the formula of the board, theta over 360 times 2 pi r. Before we look at perimeter of this sector, what is perimeter? The perimeter of any plane shape is the total length of the outer edges or the outer boundaries of that shape. The perimeter of any shape is the total length of the outer edges or the outer boundaries of that shape. For us to get the perimeter of a sector, we have our arc, and the length of our arc is already established, theta over 360 times 2 pi r. We now add it to our edges, and our edges here are two radii. So we add, the plural form of radius is radii. So when it's more than one, we say radii. So we add our length of arc to our two radii to get the formula for perimeter of sector. I say perimeter involves the total length of outer edges or outer boundaries. So we have to sum up all of these edges to get our perimeter. And we have already established the formula for the length of an arc to be theta over 360 times 2 pi r. And we sum it to our radii to get the formula for calculating the perimeter of sector of a circle. Remember I said earlier that the sector of a circle is always bounded by an arc and two radii. So having established this formula, we now apply it in solving problems. Alright, calculate the perimeter of a sector of a circle of radius 7 cm. The angle of the sector being 108 degrees if pi is 22 over 7. For us to calculate the perimeter of this sector, we first make a sketch of the sector. We say it has radius 7 cm, so we have 7 cm, 7 cm. The angle of the sector being 108 degrees. angle 180. And that we take pi as 22/7. Remember our formula for perimeter of a sector. Theta over 360 times 2 pi r, then plus 2r. Our theta is 108 degrees, all over 360 times 2, and our pi is 22/7 times radius of 7 cm. Then plus 2 times our radius, which is 7 cm. 2 times 7 cm. At this point, we cancel out. 7 into itself is 1, 7 to 14 is 2. Then we can further cancel. 2 into itself is 1, 2 into 360 is 180. So what we have there left is 108 times 22 times 2 times 2 all over 108 times 22 times 2 all over 180. And now we also have our plus 2 radii. Here you can see divide. 2 into itself is 1, 2 into 180 is 90. 9 into 108 is 12. 9 here is 10. 2 into 10 is 5. 2 into 12 is 6. So we are left with 6 times 22 all over 5. 6 times 22 all over 5, then plus our 2 times 7. At this point, 6 times 22, if we multiply that, should give us 132 all over 5. Now, then plus 2 times 7, we have 14. 5 into 13 is 2 times remainder 3. 5 into 32, we have 6. We have 6. 5 into 13, we have 2 times remainder 3. 5 to 32, we have 6. Okay, sorry, our radius is 7, not 14 cm. But we have 2 pi r, 2 times 22/7 times our r, which is 7, not 14 cm. At this point, we have 108 over 360 times 2 times 22/7 times 7 plus our 2r. We divide. 7 into itself is 1, 7 here is 1. So we have 2 into itself is 1, 2 here is 180. We are left with 108 times 22 all over 180. 108 times 22 all over 180. Then plus our 2r, which is 14 cm. That's 2 times 7. At this point, we keep dividing. 9 into 180 is 20. 9 into 108 is 12. 2 here, or 4 into 20, we have 5. 4 into 12, we have 3. We're left with 3 times 22 all over 5. It gives us 66 over 5. 5 into 6, we have 1. Remainder 1. 5 into 16, we have 3. Remainder 1, that's points. Into 10 is 2. So we have 13.2 cm plus our 2 radii, 14 cm. If you add this together, we have 27.2 cm. So our perimeter of sector of a circle with an angle 108 degrees and radius 7 cm is 27.2 cm. Let me run through it again. Calculate the perimeter of a sector of a circle of radius 7 cm. The angle of the sector being 108 degrees. If pi is 22/7, we draw our sector. Remember, it has an arc and 2 radii. And we write out our formula: theta over 360 times 2 pi r, then plus our 2 radii for perimeter of a sector. Our theta is 108 all over 360 times 2 times pi 22/7 and r 7 cm, not 14, 7 cm. Then plus our 2 radii, which is 2 times 7 on the board. Here 2 into 360, we have 180, 2 cancel itself. 7 will cancel 7 one time. We are left with 108 times 22 all over 180. 108 times 22 all over 180. 9 into this will give us 12. 9 into 180 will give us 20. 4 into 12 will give us 3. 4 into 20 will give us 5. So we are left with 3 times 22 all over 5. 3 times 22 gives us 66 over 5. If you divide 66 by 5, you get 13.2 cm plus our 2 radii, which is 14 cm. So our perimeter of our sector, if the sum of our length of arc and our 2 radii, we get 27.2 cm. So we say perimeter of a sector is 27.2 cm. But the area of sector, we are done with perimeter of sector. We now look at the area of sector. The formula we use for perimeter of a sector is different from that of area of a sector. The formula for area of a sector is given as theta all over 360 times area of a circle. Theta all over 360 times area of a circle. And we know that the formula for finding the area of a circle is pi r squared. So the area of the sector will be given as theta all over 360 times pi r squared. Theta all over 360 times pi r squared is the formula for calculating the area of a sector. Which subtends an angle of 45 degrees at the center of the circle of radius 14 cm. We first begin by drawing our circle, center O. We are told the sector of a circle, so we have of course, these are radius. Radius is 14 cm, an angle of 45 degrees. We have to calculate the area. Then the formula for area of a sector, we say is theta over 360 times pi r squared. Theta over 360 times pi r squared. Our theta is 45 degrees, so we have 45 over 360. Our pi is 20 over 7, and our radius is 14 cm times 14 cm. This we have r squared is r times r. So we have 14 cm times 14 cm. So at this point we divide. 7 into itself is 1, into 14 we have 2. 45 into itself is 1, into 360 we have 8. So we now have 22 times 14 cm times 2 cm all over 8. 2 into itself is 4, 2 into 2 is 1. 2 into 4 is 2, 2 in here is 11. 2 here is 1 and 2 here is 7. So we are left with 11 times 7 cm squared. So this will give us 11 times 7 is 77 centimeters squared. So our area of sector is 77 cm squared. Let's go again. We have calculate the area of the sector of the circle which subtends an angle of 45 degrees. So here we have our angle, and the center of the circle of radius 14 cm. We have our radius of 14 cm and 14 cm. We have to find the area of the sector of that circle, and we have our formula on the board: theta over 360 times pi r squared. Our theta, as we know, is 45 over 360 times pi. We have 22 over 7 times r squared, and I said r squared means r times r. That's radius times radius. We now divide through. 45 into itself gives us 1, into 360 gives us 8. 7 into itself is 1, 7 into 14 is 2. We are left with 22 times 14 times 2, all over 8. At this point, 2 into 8 is 4, 2 into itself is 1. 2 into 4 is 2, 2 into 14 is 7. 2 into itself is 1, 2 into 22, we have 11. So we are left with 11 times 7. And 11 times 7 gives us 77 centimeters squared. So the area of our sector of that circle of an angle 45 degrees and radius 14 cm is 77 centimeter square. The arc of a circle of radius 20 centimeter subtends an angle of 120 degrees at the center. Use the value 3.142 for pi to calculate the area of the sector correct to the nearest centimeter square. So we already know the formula for finding our area of sector of circle. Theta over 360 times pi r squared. And we know that our radius is 20 cm. On the question, our theta angle is 120 degrees. And our pi, this time around we are to use 3.142. Now we compute. Our theta is, we have 120 all over 360 times pi, 3.142 times our radius, 20 cm times 20 cm. 0 will cancel 0. 12 here is 1, 12 here is 3. So we have 3.142 times this length. 3.142 times 20 cm times 20 cm all over 3. 3. We have 3.142, 20 times 20 will give us 400, and 400 cm square all over 3. If we multiply that, we get 1256.8 all over 3 cm square. If we use our calculator to divide that, we get 418.93 cm square. But the question says to the nearest centimeter square, meaning to the nearest whole number. So this will give us 419. See, after our point we have 9. 9 is more than 5, so we round up to 9. 8 becomes 9. So we have 419 cm square to the nearest cm square. The arc of a circle of radius 20 cm subtends an angle of 120 degrees at the center. Use the value 3.142 for pi to calculate the area of the sector correct to the nearest centimeter square. Now the sub-area of sector is given as, you can draw the diagram if you wish on the board. You can also draw the diagram still, the same process we have been using. Center O, we have an angle of 120 degrees. Then our radius is 20 cm, so you can draw it if you wish. That's our sector of the circle. And define the area. So we compute. Theta is 120. We have 120 over 360 times our pi, 3.142 times 20 times 20. 0 will cancel 0. 12 into itself is 1. Into 36 we have 3. So we are left with 3.142 times 20 times 20 all over 3. We have it here 3.142 times 20 times 20 all over 3. We multiply this, we get 400. So 3.142 times 400 all over 3. If we use our calculator to multiply this, we get 1256.8, then all over 3. We divide to get 418.93 cm square. So the question says correct to the nearest cm square. So we round up to the nearest whole number, and that will give us 419 cm square. Of the circle has an area 55 cm square. If the radius of the circle is 10 cm, calculate the angle of the sector. In this case, we are given the area of the sector as 55 cm square, and we have to find the angle of the sector, or to find the angle which is theta. So, of course, we know that our theta is not given. Our pi here is 22 over 7. Our area of sector is given area of sector is given as 55 cm square, and nothing else is given. Okay, we establish a formula: theta over 360 times pi r square. That's the formula for calculating the area of a circle. Sorry, our radius is 10 cm. So this formula, we compute it to get, you see, a sector of a circle has an area of 55 cm square. So this formula will give us equal to 55 cm square. Our theta is what we are looking for. So we say theta all over 360 times pi is 22 over 7. Pi is 22 over 7 times our radius. R square is 10 cm times 10 cm. That's all equal to 55 cm square. Okay. From here we cross multiply, but yes, we can cross multiply from here. But let's divide a little. 0 will cancel 0. So we are left with theta times 22 times 10 cm all over 36 times 7 equal to 55 cm squared. That's from here, theta times 22 times 10 cm all over 36 times 7 is equal to 55 cm squared. Now at this point, this can be written as all over 1. We can cross multiply. But before we cross multiply, let's divide a little. 2 into 36 will give us 18. 2 into 10 will give us 5. Right? 2 into 18 will give us 9. 2 into 22 will give us 11. So we now have theta times 11 times 5 all over 9 times 7 equals 55 cm squared. That's it, all over 1. At this point, we cross multiply. That's theta times 11 times 5 times 1 is equal to 9 times 7 times 55. As soon as we cross multiply, this multiplies by this and this multiplies by this. Theta times 11 times 5 times 1. Theta times 11 times 5 times 1. Then 9 times 7 times 55. 9 times 7 times 55. Now we have to look for theta. Theta will now be equal to 9 times 7 times 55 all over 11 times 5 times 1. 5 into itself is 1. 5 here is 11. 11 here is 1. 11 here is 1. So we have theta as 9 times 7 equals 63 degrees. So our theta is 63 degrees. So the angle of the circle of radius 10 cm and area 55 cm squared is 63 degrees. Let's run through it again. The sector of the circle has an area of 55 cm squared. If the radius of the circle is 10 cm, calculate the angle of the sector of that circle using pi as 22 all over 7. So we apply a formula theta over 360 times pi r squared. Remember we are looking to look for our theta. So we say theta over 360 times our pi is 22 over 7 times our radius is 10 cm. We have times 10 cm times 10 cm because we have r squared. All this will give us equal to our area, which is 55 cm squared. Here we divide, 0 will cancel 0. We are left with theta times 22 times 10, theta times 22 times 10, all over 36 times 7. 36 times 7, all equal to 55. You can write all over 1, it's still the same thing. 2 into 36 we have 18, 2 into 22 we have 11, 2 into 18 we have 9, 2 into 10 we have 5. So we are left with theta times 11 times 5. Theta times 11 times 5, all over 9 times 7, 9 times 7. All equal to 55, all over 1. Now we can cross multiply. When we say cross multiply, this will multiply by this, while this will multiply by this. So we have theta times 11 times 5 times 1 here. The same thing, theta times 11 times 5 times 1 equal to 9 times 7 times 55. 9 times 7 times 55. At this point, we look for theta. So theta will now give us all of this 9 times 7 times 55 all over 11 times 5 times 1. 11 to itself is 1. Sorry, 5 into itself is 1. 5 into 55 is 11. 11 counts 11 one time. So we are left with 9 times 7. So 9 times 7 is 63, meaning our theta is 63 degrees. The end of the class. This is going to be an assignment. You have to complete this table we have on the board for area of circles of the circle. Please show working. Don't just fill in the blank spaces for me. Show working and fill in the blank spaces for me. Don't just fill in the spaces. You have to show me how you got your answers. And here we have the area of the circle. So area of the center of the circle, PQR with center O. Of the circle to be 72 cm. We are now to find the area of the sector of that circle. Please draw your sketch for this diagram before solving it. I'll be expecting your assignment soon. Let's hope that very soon the pandemic will be over so that I will see your faces again. Stay safe and be good children. Goodbye. See you next week.